tell you it's, what is it, 2.10 meters. So. And the question is, this blue player here, how fast does he have to run back in order to get and hit that ball when it's 2.10 meters above? That's the ultimate question right there. Now, to answer that question, we basically need to know two things. We need to know, well, look, he's got to run from here to here, yes? So he's got to run this distance back. We need to know what that distance is, yes? And we need to know how much time he has to run that distance. And then as soon as we know how far he's got to run here and how much time he has to run here, we can calculate the velocity by just using good old velocity is equal to distance divided by time. So our mission really becomes twofold. We need to calculate this distance, calculate this time, and then we can divide the two to get the person's velocity. You with me? Okay. They tell you in this problem that the ball was hit this way with a speed, is it 15 meters per second? And they tell you this angle in here is 50 degrees. So with that information, we're going to be able to calculate how much time it's going to take for the ball to go to here. And we're going to be able to calculate how much distance there is between here and here. Just by that given information and this vertical height, 210 meters, we're going to be able to calculate how much time it takes the ball to go to there, and what this other distance, I'm going to call it big distance D. We're going to be able to calculate those. And I need to also point out, they tell you that the original distance between the two players is 10 meters. Okay? So what we're going to do now is analyze this motion right here. Okay? So let me go to a new page. So if that projectile was shot this way at 15 meters per second, we know that it's sort of going horizontally and it's sort of going vertically, yes? And what we're going to need to do is use trig to figure out how fast is that projectile going in the x direction and how fast is the projectile going in the y direction, yes? And basically, if you do enough of these, you know that the initial velocity in the x direction is going to be equal to 15 meters per second times the cosine of 50 degrees. And VIY is going to equal 15 meters per second times the sine of 50 degrees. Little calculator help. 9.64 meters per second. 11.4 meters per second. So 11.5. Are we good? Good to go? So then we could break this down into two motions. There's a horizontal motion going on, and there's a vertical motion going on. So, as always, we know that the acceleration in the x direction is going to be 0 meters per second squared. But the acceleration in the y direction is going to be equal to negative 10 meters per second squared. And we know that the initial velocity in the x direction, help me out there, 9.64 meters per second. And the initial velocity in the y direction is 11.5 meters per second. And then we know that the vertical altitude gain is, what was that? 2.10? And basically what we want to know is how far did it go horizontally during that? Yeah, but I think it's a little bit more complicated because we're going to have a quadratic diff-off. So once again, the time that it takes to go horizontally is going to be the only thing that's equal in the two columns. That's the same time that it takes to go vertically. And we have enough information in the vertical column, so we use the great distance formula, x, y equals vi y times t plus 1/2 at squared. Oopsie. So I know this is 2.10 meters. And this is going to be 11.5. Yeah, last time the t was 0. I'm sorry, the initial velocity vertically was 0. 1/2 times negative 10 times t squared. So you're going to have a quadratic to solve. So I would rearrange that so it's in the good to go mold. So what's that going to be? Negative 5 t squared.
Tim Harris, please go to Michael Salton's office. Once again, Tim Harris,
Plus,
please go to Michael Salton's office. Thank you.
And I'll say plus negative 210. Yes. You put that in polysimul. What'd you do?
Basically the same thing. I didn't, like, you know how you have negative 5 t squared from there?
Yeah.
I didn't do it from there. I just have right there. And then from there.
Oh yeah, how'd you get those two values?
And then I graphed it.
Okay.
But
You could graph it, or you could use the quadratic formula. You, I'll give you guys All right. Let's finish up this problem I give to you guys, okay? So then, what do you get for the 2 times? 0.2 seconds, and t equals 2.1 seconds. And what's up with that? Which time do we want? The 0.2 seconds or the 2.1 seconds? Well, let's go back to the original problem over here, yes? Those 2 times that we just found,
Will Tim Harris or any custodian please call or come to the main office? Once again, will any custodian or Tim Harris please come or call the main office? Thank you.
those 2 times that we just solved for, they tell us when the tennis ball had an altitude of 2.10 meters positive above the initial starting point. Look, when you first strike it right here, yes? Right here, it was also 2.10 meters above. Right there. Okay. And then a little while later on the way down, it was also 2.10 meters. So which time do we want? The second one, yeah. The first 0.2 seconds, that was on the way up, right here. So we want this time here. So then we go back over to the horizontal, and we can figure out how far it went horizontally, yes? What do we got there? No, let me finish this up. XX equals p.80 plus 1/2 a t squared. XX equals vi 9.64 meters per second times 2.1 seconds. And we know that the horizontal acceleration is 0. So what'd you end up getting for the horizontal there? 20.2. All right, stay with me though, because there's a couple more little tricks. So now we go back to that original page. What we just solved for was the big D, yes? Okay, so we know big D was like, what is it, 20.4? So if you subtract 10, then you're going to get your x value that you want right here. So 20.2 minus the 10 meters gives you your, whatchamacallit, your x value, how far the guy's got to run back. So he's going to have to run back basically 10.2 meters. If it's the ball travels a total of 20.2 meters, but there's already 10 meters between the two, then the player only has to run back 10.2 meters. No, that gives you this value right here. So that gives you this, 10.2 meters. But wait, there's one final little trick to this problem. Okay. How much time does the player have to run back here? Because that's the last thing we need right here, yes? If we know the time, we could plug it in here, and then we could get that velocity, yes? Well, we know how much time it took the ball to go from here to here, yes? How much time did it take the ball to do that? 2.1 seconds, yes? But you see this player right here? human reaction time, he doesn't react immediately. The ball gets hit, he's got to react, and then he starts running back. So it's like 0.3 seconds before he even starts moving, yes? So if the ball takes 2.1 seconds to go to this altitude of 2.10 meters over there, yeah, he doesn't have the whole time because he wastes some of the time, reacting and all. So basically, the 2.1 seconds minus the 0.3 seconds reaction time gives you 1.8 seconds left for him to get back to the ball. So we know this here is 1.8 seconds, and then if you divide that out, what's 10.2 divided by 1.8?